So following on from the previous video, we were trying to work out the area that exists in between two vectors. The area that exists in between the two vectors. So the area is given by this, but the thing is, we only know how to work out cos of this angle here, but we need sine of that angle. So we need a way of getting from cos to sine, and then we got to this stage here. We got to this stage here where this angle here is theta. This angle here, we're going to assign it a new name. Theta prime, and theta prime is given by this. So now the hard part, this bit is hard to visualize. Bear in mind that this is 90 degrees. Okay, so from here to here is 90 degrees. This angle here is theta. This angle here is theta prime. So now if you draw a right angle triangle here, so this is your right angle triangle here. If you look at this, sine is this thing, and the magnitude of b is the hypotenuse. So this length here is given by the magnitude of b sine theta. That will then give you this length here. So now looking, hang on, let me erase this. So now looking at this angle here, this angle here is theta prime. Hang on, let me just draw O. So this here is 90 degrees. This bit is hard to visualize. I will try and elaborate on it, but just hold out on this. So this angle here is theta prime. Now if you look at the so keep your mind on the hypotenuse. Now the magnitude of the hypotenuse is the magnitude of b. Is the magnitude of b. So imagine this vector b here is the hypotenuse. So cos. So this is our cos here. So this is our adjacent here. So the magnitude of b, and then cos theta prime. So that this thing here will then give us this length here. Okay, will then give us this length. The point here is that this length here, which is this thing here, is the same as this thing here. So when you set this to be equal to this, the two b's will cancel each other out. So cos theta prime equals sine theta, which is this thing here. And don't forget, this thing here is cos pi over 2 take away theta. So when that equals this thing here, it's quite hard to visualize this. Let me just elaborate on this. Imagine you've got a unit circle. Before I do that, the reason why it's hard to understand what's going on here is let's rotate this so that we have a vector that's horizontal. So this is still A, and then B will be somewhere around here. The reason why it's hard to see, is because it's at an angle. So let's just imagine this as our xy axis, and then this hang on, let me think. This angle here is theta. That's this angle here, theta. So now you can see. Imagine the vector b as being your hypotenuse. So when you get the magnitude of b, sine the angle, that will then give you this height. But then now, don't forget, when you rotate it 90 degrees, this angle here will be theta prime, which is this angle here. This is hard to visualize. This is much easier to visualize. So now keep an eye on b, the vector b, which is the hypotenuse. Now if you cos the hypotenuse, if you get the magnitude of b, and then cos theta prime, cos this angle here, that will then give you this length here. That will then give you this length. Well, this length here is the same as this length here. So the two b's will cancel each other out. So you can see that this will equal this. And there's another way for me to try and convince you, which I will do in the next video. Okay.